Hello, everyone. A little housekeeping note. We'll be starting this session soon, and we'll be recording this for posterity so you are all aware. Any questions that were not addressed will be answered by email. This presentation will eventually be available for on-demand viewing on the Wiley Science Solutions website at sciencesolutions.wiley.com in the webinar section. Good day, everybody. My name is Mark Lucchetti, Field Marketing Manager with Wiley Science Solutions. Welcome to today's webinar entitled, What's New in KnowItAll 2026? It is my pleasure today to introduce you to our speaker for this informative session, Product Manager, Software Products, Dr. Michelle D'Souza of Wiley Science Solutions. Dr. D'Souza brings years of insight and knowledge in the area of spectral informatics with leadership roles at both Wiley and Bio-Rad Laboratories, in addition to her multiple years as a scientific researcher at Abbott and DuPont. She has a PhD in chemistry from Northern Illinois University and the master's in analytical chemistry from the Chinese Academy of Preventive Medicine. She earned a Bachelor of Science degree from Chemistry Department of Beijing University as well. We are excited to have Dr. D'Souza present us today her webinar entitled What's New in KnowItAll 2026. We do encourage the audience to submit questions, which will be addressed at the end of the session. So with that, I will turn that stage over to Dr. D'Souza for her presentation. Take it away, Michelle.
Thank you for the introduction. Now we will take a look at what's new in KnowItAll 2026 release. Today's agenda is we'll go over what is KnowItAll, the new tools added, and additional updates. In the end, we will have a Trendfinder new tool demonstration. KnowItAll is an integrated solution to identify unknown compounds, analyze spectra, and manage analytical data. It is combined with Wiley's comprehensive high-quality spectral reference databases. This diagram shows how KnowItAll pulls all kinds of functionality together in one environment. The important one is comprehensive spectral databases used by KnowItAll. They can be applied into different fields, and you can separate them by techniques, as shown here on the very right. So today we'll take a look at new tool added for 2026. It's called Trendfinder. Trendfinder basically is a principal component analysis tool to uncover meaningful patterns and trends in complex data sets. You can use your own data or tap in KnowItAll's database to explore correlations between data. It's added into analytical data, so no additional cost. This tool is very intuitive to use, so it should have very low learning curve for people who are not familiar with the PCA analysis. Here are some examples. We will have detailed webinars on all these examples. Okay, so I'm going to go very brief here. The first one is 200 pin chips IR spectrum. You cannot easily make too much sense out of this collection, right? But if you put into KnowItAll Trendfinder, you would see clear separations depending on pin type. For example, the green color and black colored spots are all lacquer paint, and then the blue, brown, and purple color all enamels. What is Trendfinder can do is not only it offers PCA analysis, it also allows you to project unknown pin types into this PCA space, therefore to classify them. For example, here, you can see we have two spots put in here, and then they're in the, one is in the lacquer space, one is in the enamel space, so they're different paints. This is an example for each proton NMR. Okay, this is a collection of blood sample of two types, normal or diabetic population. Just by looking at NMR example, you can't. There's a lot of data, but there's no information, right? The water is removed here, but you can't tell diabetic versus normal population. So you put that into the Trendfinder, you would find along factor 1, you have separation here between normal population on the left and diabetic. You can use this factors loadings plot to perform spectral match, peak match actually. Not spectrum. You can't treat, this is not a real spectrum, so it's peak match. And you can find the corresponding compounds that drives population into the positive region, which is diabetic. So this is a way to find a marker compound. The third example, which will be in the demonstration today, is a collection of 200 random LC-MS, which is tandem mass spectrum. When you look at them as spectrum, they don't tell you much. But if you put them into our Trendfinder, you can see distribution. Very interesting that you have a cluster here, which is black color. They are all low energy MS spectrum. Okay, it's all low collation energy. And the higher collation energy spectrum all scattered and then pushed out of this PCA space. That means they are very different from the origin. They are which also consistent with the chemistry that the higher the energy, the more small fragment you have. And it's very different from lower energy where you have probably 1 or 2 peaks. Additional thing you can do to examine this dataset is to see what is the most popular fragment among them. As you can see, this benzene ring is second popular. In 200 compounds, 186 have benzene ring. Importantly, I'm interested in this little star here, okay? The little star corresponding to 20 collision energy 25, but it is in a space pretty scattered out, close to higher energy, collision energy, MS spectrum. So I'm taking a look of that, okay? I'm clicking on that because we are in KnowItAll environment. Easily you can go to the record itself. As you can see that this compound has a multiple collision energy. The lower collision energy on top here is very simple. It has 2 peaks, okay? And with the increasing of collision energy, you have more and more peaks, which is consistent, okay? The 25 collision energy is this green spectrum here, okay? As you can see, when you increase the collision energy, you see less fragmentation pattern. Okay, you lose some peaks, but there's no more new patterns coming out. But compared to the origin, it is very different. It's 25, very different from the origin 2 or 3 peaks. So it's good. So let's take a look at additional updates in KnowItAll 2026 release. First, we enhanced our security, code security. Okay, we've been through an audit process and identified removed vulnerable codes. And we offer Microsoft installer deployment of KnowItAll. We have one more language. It's localized in Korean language now. Inchi is updated to 1.03 because we have structure. We generated Inchi keys. So we want the latest. We have a new file filters added, Shimazu MS LCMS file, and also analysis file formats. Okay, for the LCMS, you can batch process raw data. Okay, and then has more database search controls, and also we mentioned that has Shimazu filter. Also in LCMS area, one can specify to manually add peaks that is missed by automatic deconvolution on different levels. And also one can manually actually analyze peaks instead of make it automatic process. And also in search it to help MS search, we add a partial spectrum search, which means your unknown spectrum doesn't have to have all the does not have to be penalized by like a full spectrum. It's not a full spectrum. Okay. And also, we offer this new algorithm just to do peak M over Z search without considering intensity. For NMR, we have a button for user to easily click, and then we automatically assign the splitting patterns, which can be adjusted by user manually. That helps a lot of save a lot of time. Okay, we fix a bug that when we read in geo field spectrum file. For the GC-MS, we renamed MS export to GC export. That's the first thing. Second, when you transfer a spectrum to be searched in the search it, the databases you set GC-MS to use is carried over, so you don't have to do reset there. And also, we allow people to display labels for both the extract spectrum versus the reference spectrum. In search it, when you have a GC-MS, we automatically allows you to have option of specify your retention index to go with that GC-MS spectrum. That would narrow down your search considerably. And when you have a mixture analysis, if you have a mixture, and then we allow user to set up tolerance, the difference between two components, because when you have a co-elute situation, only similar, very close retention index should come out together. It'd be ridiculous to have drastically different retention index to co-elute. And for search it, one can just paste a list of your value like cast number, and KnowItAll construct a complex search query for you. So it's very convenient if you have a list of, say, cast numbers you want to search in KnowItAll. For ID export, we allow people to use manually selected databases to perform quick search. Before that, as you know, we will only use the entire data collection. For MindIt, if you build databases, you may be interested in that. You can change a property of a data into another property. For example, molecular weight can be changed all under, you can move the whole value to nominal mass if you want to. And also, if you build databases, there is a history tab in database, so you can see what you have done, what is changed. And also, sometimes our structure is too small. You can set a zoom in our structure display pane. Okay. Database installation for reference database, you can have a choice to install it or move it to a different location rather than default location. Default location is on C drive. You may want to move to D drive. When you install database, you can manage the move, as you can see, browse to new location or new location. So this is a neat feature when you have limited disk space. Okay, now that's the major changes in KnowItAll. Now we are ready to perform a demonstration of our new application Trendfinder. Okay, what you are looking at is 2026 release of KnowItAll informatics system. In case you don't know, KnowItAll organize its applications in two boxes. For example, when you open KnowItAll, you first see the toolbox to be data toolbox. In it, you have data search and database reviewing. We do have other tools in various toolboxes. For example, under basic, we have cam window, report it. And today I'm going to draw your attention to a new tool in the spectral analysis toolbox. It's called Trendfinder. By its name, you know that is to looking for a basic trend in a collection of data. So I'm going just to directly go in there and then perform analysis. Okay, now I am going to show you that is for tandem math, tandem MS spectrums research. Okay, say you go to search it, you want to search our tandem math database, LC. And then you want to say, I'm not going to do peak search. I'm going to do structure similarity search. I am going to open a structure file. I'm going to open a structure file. Okay. And I want to do similarity search, and I want 200 hits coming back. I got my hits, but if you select your entire hit list, 200, you really can't make any sense out of it. Okay, you can use the heat map to look at them. No heat map. This is too many. It's because overlapping. I'm going to reduce it. Okay, you can see a bar chart here. It doesn't make any sense. You can't make out what this data set is trying to tell you, right? Now let's throw it into PCA to see if PCA can reduce the complexity of data. So we throw it into Trendfinder. Okay, this is transfer again. You transfer what you have here to another application. Where I want to start a new analysis. Okay, so 200 records is taken in, and I'm going to analyze the mass spectrum. I don't need to specify classification. I just want to see its natural distribution. Here, again, I'm not going to change the pre-processing, but I will use a method commonly used for mass spectrum is a sample max, okay, divided by sample max. Comes in here. I got my result. It's just scatter plot. Each one is a mass spec, tandem mass spec, okay, pointing to an original record. Doesn't make too much sense yet until I say, okay, I want to see, give me the collision energy. So the correlation energy have different levels, 5, 10, 15, 20, until 50. Okay, so when I look at this graph, I see lower collision energy spectrum cluttered together. It doesn't matter what spectrum you have, maybe a totally different compound, but they all look similar. That sounds counterintuitive for chemists, but you think about it. Math only see 1 peak, 2 peak, or 3 peaks. So they all look similar. They haven't, because the collision energy is so low, they didn't break into many fragments. So the mass spectrum of them in the mathematics world look similar. And then the spectrum that have high collision energy is spread out because with high collision energy, you break the compound into small pieces, and then a different compound would have different small pieces. So they are very different from its origin and from each other. What piqued my curiosity is this particular little star here. Let me click on it, okay? Because this is a spectrum with 25 EV collision energy. So if I click on it, I could look at the record itself, but it's still not clear. I know it's a structure, basic structure, okay? But it's not clear. So what I'm going to do, if I click on this, I'm going to go to the database record. So this is beyond the simple PCA now. Okay, you go back to that record. What you see is this is the spectrum of 25 EV collision energy. Okay, and I'm going to squeeze in a little lower. And then if I compare that with next 30, as you can see, if I put them together like this. Okay, as you can see, they're not too much different from each other. That means you increase the collision energy. You didn't break this molecule further. Okay, but if I check to see this one versus 20, you know, again, it's next to each other. The energy level is similar, not too much different. But if I go to the origin, sorry. Okay, now I'm going to compare 5 to 25. You can see the difference in spectrum. So for PCA, the original spectrum is very different from the 25 collision energy spectrum, which makes sense in chemistry. Okay, so that graphic, I'm going to close this window. This graphic totally makes sense and then really give you a different perspective of chemistry. Okay, we don't stop here. We did many things to make this application exploratory for users. Okay, so you can, for this data set, 200 compound, you can calculate what kind of substructure they contain. So it goes to the database record, analyze substructures in this data set, and you can sort by it. You can sort by the abundance, okay, of substructures. Okay, and you sort up and down by abundance of substructure. Obviously, this one is the most abundant one. Of 200 records, 196 have this kind of conjugated fragment, and then next populated one is benzene. So you can do many things with the PCA analysis in KnowItAll. Especially it's tied to its original reference data, so it's well curated data set. And also it's not limited to just the 3 data set I showed you. It's applicable to IR, Raman, UV, NMR, GCMS, and LCMS.
This is now the end of my presentation. We'll now move on to the Q&A session to answer your questions.
That was a great webinar, Michelle. Thank you very much. Folks, we've reached the end of our presentation today. Thank you, Dr. D'Souza, for your time and expertise to present us your talk on what's new in KnowItAll 2026. We'd like to now open up the session to some questions from our attendees, which if you can please type in using the questions toolbar, that would be great. So let's see what we have here. Here's a good first one, Michelle. What is unique in Wiley's Trendfinder PCA app?
Yeah, the PCA engine, the core portion is just like a regular principal component analysis tool. Nothing much new there, but what is new in Wiley's tool is application of it. It applies to different technologies, and because we have massive data for each technology, then people can find some useful information out of it. Such as you can use a scores plot. Once you're done, analysis can put unknown into the project into scores plot and find out where they belong. So it's very interesting tool to do that. And in the next few weeks, we'll present in detail the PCA analysis. And also one can use loadings plot. If you have only 2 classes, you can use loadings plot as if it's a spectrum and then perform peak analysis, so you can find out what peaks separate 2 different classes, and from there what are the markers to distinguish 2 different classes. It will present it next few weeks also. And also our, as you can see from from LCMS example, we demonstrate here that because our database is so well documented, the metadata is rich, so you can really explore the data relationship with the structure. You need good data, so we take advantage of Wiley's database to do that. So those are unique features that comes along with the PCA analysis and helps the PCA analysis.
Great explanation. Thank you very much, Michelle. Here's another one, sort of similar, related. It's, is the new Trendfinder applicable to Raman databases?
Yes, it is. Raman databases, you can use similar process like IR, which will be demonstrated next week. No, next few weeks again. Yes, you can use that to find interesting trends in Raman.
Great, thank you, Michelle. Here's one. I am currently using KnowItAll for IR analysis. I also use GCMS in my lab. Am I able to get a trial of the GCMS?
Yes, please contact to our website or our sales manager. We do offer trials, so people should go for it.
Yes, they can access the request a quote link on our website as well.
That's correct. Yeah.
Oh, here's a very interesting one. So why did Wiley prioritize the strengthening security in this release?
We will continue to do that in the older releases after that. We know we want the customer to feel safe to use our products within their organization. So we are proactive to be in line with the highest standard for that regard. So we'll continue to do that. Always pay attention to the security, software security.
Great. Thank you, Michelle. Let's see, we might have time for another one here. Can you tell me a little bit more about spectral data management in KnowItAll? You had mentioned that audit trails being added, but I wanted to know more about building databases in general.
The databases, Wiley has the best, KnowItAll is I think is the best database building tool. For example, you can combine, you can put in one record, a spectrum record, all the different type of spectrum, or the same type but multiple runs. It's very flexible and doesn't limit you to the spectrum range and all this, and apply application for it. And we're very careful to track data from beginning to the end. As soon as it entered our database, we track the changes into those data so people can have a trail of record of changes made to the original data. So you can export in that also.
Great, thank you, Michelle. Here's another one sort of related to one of the previous questions. Given the limited libraries contained in the Raman database, is the usefulness of Trendfinder limited to the size of the Raman database?
That's a very good question. From my experience, this is depend on how complex your data is, how many classes it's within your Raman collection. Okay, from my experience, you need about 40 spectrum. If you have two classes distinguishable, you can need about 40 different spectrum to see the trend in it. But anything beyond that is great. The more the merrier. But you can't have too many different kind of classes to study at the same time. So it depends on how you can visualize the separation of data. People should try to push the limit.
Always. Well, I think we've reached the end of our time today for questions. I'd like to thank our product manager, Dr. Michelle D'Souza of Wiley Science Solutions, for taking the time to present us our talk on what's new in KnowItAll 2026. Great job, Michelle. Any questions that were not addressed will be answered by email. This presentation will eventually be available for on-demand viewing on the Wiley Science Solutions website at sciencesolutions.wiley.com in the webinar section.